101 times. That is how many times a single volcano in eastern Indonesia detonated in a single 24-hour period. Not trembled, not vented, not sighed the quiet breath of a geological system adjusting itself. Detonated. Each blast generating a seismograph amplitude between 14 and 28 millimeters, each explosion lasting between 32 and 81 seconds, each one stamped into the scientific record by the instruments at the pvmbg monitoring post in Gam Icy Village as a distinct, independent, fully formed eruption earthquake. 101 of them, in a row, one every 14 minutes and 22 seconds, like a heartbeat that will not rest. But that is not even the real story. 101 eruptions in 24 hours sounds extraordinary until you understand what those numbers are sitting on top of. Until you understand that this mountain, Gunung Ibu, the stratovolcano on the northwest coast of Halmahera Island in North Maluku Province, Indonesia, has not truly stopped erupting since April of 2008. 17 years. 17 years of continuous eruptive activity, a geological drumbeat that the world barely notices because it sits on one of the most remote inhabited islands in the entire Indonesian archipelago, 700,000 people living on a landmass the world mostly forgot about, until the numbers from the seismographs began climbing in ways that make volcanologists pause and look twice. In 2023 alone, pvmbg, the Pusat Vulkanologi dan Mitigasi Bencana Geologi, Indonesia's Center for Volcanology and Geological Hazard Mitigation, recorded 21,100 eruptions from this single mountain. 21,000. That made it the second most active volcano in the entire country of Indonesia, a country that contains 127 active volcanoes and sits on the most tectonically violent stretch of the entire Pacific Ring of Fire. The 101 eruptions in 24 hours that triggered the Level 2 warning alert are not an anomaly. They are a chapter in a story that has been building across 2 decades, and what the data actually shows is that this mountain is not expressing itself. It is accelerating. Gunung Ibu stands at 1,325 meters above sea level. That is 4,347 feet. Not a giant by global standards, not a Kilimanjaro or a Fuji, but geological scale is not measured in height alone. It is measured in what lies beneath. Before 1998, if you had asked a volcanologist about Gunung Ibu, they would have told you it was known to science primarily from a single small explosion in 1911, a volcanic explosivity index of 2, lasting 3 days, then silence. After that brief expression in 1911, the mountain went quiet for 87 years. 87 years of agricultural seasons, of communities building their lives on its flanks, of a dormancy long enough that a human generation could grow up, grow old, and die without ever witnessing this mountain do what it was built to do. Then, December 1998 arrived, and the quiet ended. Explosions began. A lava dome grew inside the summit crater. The dome expanded slowly, filling the inner crater over subsequent years, until it covered much of its floor. In April 2008, the current eruptive period began in earnest and has not stopped since. The mountain that slept for 87 years has now been erupting continuously for 17. The lesson written in that timeline is one that every community living near a historically quiet volcano should memorize. Dormancy is not permanence. Silence is not safety. The geological clock does not announce when it resets, which means it is built from alternating layers of hardened lava and compressed ash, a composite structure forged over thousands of years of eruptive cycles, each eruption adding a new stratum, a new chapter pressed into the rock. Stratovolcanoes are not gentle. They do not ooze lava politely down their flanks the way Hawaiian shield volcanoes do. They build pressure. They hold it. They accumulate gas-saturated magma in chambers below the crust until the pressure differential between what is below and what is above reaches the point of no longer negotiable, and then they do not flow. They explode. Pinatubo in the Philippines was a stratovolcano. Vesuvius is a stratovolcano. Krakatoa was a stratovolcano. The geological family Ibu belongs to is the most dangerous category of volcano that exists on the surface of this earth. The inner crater of Mount Ibu is 1 kilometer wide and 400 meters deep. Stand at the rim and look down. That is a hole wide enough to contain a small city and deep enough that you could stack the Eiffel Tower inside it and still have room to spare. The outer crater is 1.2 kilometers wide. But here is where this story becomes genuinely alarming. The outer crater of Gunung Ibu is not a complete ring, it is breached. On the northern side, the outer crater wall is broken open, creating a steep walled valley that runs northward from the summit down toward the island below. This breach is not a crack. It is a structural absence, a gap in the containment structure that means any major eruption column, any significant pyroclastic flow, any large-scale ballistic ejection from this volcano does not have to climb over a full surrounding wall of rock before it can descend onto the inhabited landscape. And the pvmbg knows this. That is precisely why the exclusion zone is not symmetrical. The general radius is 2 kilometers. But in the direction of that northern breach, the open side, the unguarded side, the exclusion zone extends 3.5 kilometers. The asymmetry of the safety boundary is itself a measure of the asymmetry of the danger. On October 1st, 2025, between the hours of midnight and 11:59 p.m. West Indonesia time, the seismographs at the Geologi monitoring post recorded the following: 101 eruption and explosive earthquakes, 2 rockfall earthquakes, each with an amplitude of 2 millimeters, lasting between 33 and 43 seconds, small individual rocks or fragments of the inner crater wall losing their grip and falling into the active vent below. 5 exhalation earthquakes with amplitudes between 4 and 10 millimeters, the mountain breathing out, releasing pressurized gas and pulses that register as discrete seismic events. This is what a level 2 alert looks like in practice. On Indonesia's 4-tier volcanic alert system, level 2 is defined as increased activity above normal baseline, a state of watchfulness, not emergency. The public is not being mass evacuated. The fishing boats are still on the water. The children of North Halmahera are still in school. But the instruments are watching every second, and what the instruments are showing is a mountain that spent the day producing eruption earthquakes at the average rate of 1 every 8.5 minutes during its most active hours. 101 distinct explosive events in one day. Think about what an amplitude of 28 millimeters means on a seismograph recording a volcanic eruption. That is a wave of ground motion, not tectonic stress, not a distant quake propagating through the crust, but the seismic expression of a detonation happening inside the mountain itself. Each of those 101 events represents a moment when the pressure below the vent overcame the weight of material above it, when gas-saturated magma punched upward through the conduit and broke the surface violently enough to shake the ground. 81 seconds is how long the longest of those eruptions lasted. 81 seconds feels short until you're standing at the monitoring post and counting it. 1, 2, 3. By the time you reach 81, a column of ash and gas has risen hundreds of meters into the air. Pyroclastic material has been ejected outward from the vent, and the mountain has consumed more energy in that single blast than most industrial explosions produce in a controlled detonation. Then 14 minutes pass. Then it happens again. The people who feel this in their bones before any instrument registers it are the residents of the small coastal communities along the northwestern flank of Halmahera, the villages of Duono and Gamitsi, the fishing hamlets scattered along the coastline within sight of the mountain's silhouette. Gamitsi is where the monitoring post stands. The scientists who staff that post do not experience Mount Ibu as data, they experience it as sound. When the August 2024 eruption produced an ash column 5,000 meters above the summit at 2:52 in the morning, the observation report noted that a loud boom and rumbling sound were heard clearly at the post. When the June 2024 eruption sent an ash plume 5 kilometers into the sky for 265 seconds, the ash fell on Gamitsi itself, on the streets, on the rooftops, on the fishing nets laid out to dry on the shore. The residents of these villages do not need a level 4 alert to know something is wrong. They taste it. They sweep it from their doorsteps. They tell their children to stay inside. They make decisions about whether to fish today or wait, whether the sky looks safe enough, whether the mountain is quiet enough for the morning. These are not people living in the shadow of a geological concept. They are neighbors of an active stratovolcano that has been erupting continuously for 17 years. As of 2022, approximately 700,000 people live on Halmahera Island. 700,000. That is the population of a mid-sized European city, distributed across an island of 17,780 square kilometers of forests, coastlines, fishing villages, and small-scale farms. The people of North Maluku, the Tebelo and Galela and Ibu ethnic communities who have made this landscape home for centuries, sustain themselves primarily through fishing, subsistence agriculture, and small-scale farming. There is no major industrial infrastructure here, no mass transit evacuation network, no network of highways cutting through the volcanic terrain that could move tens of thousands of people in hours. When the alert level rises, the pathways out are limited. The time available is not always sufficient. And the geological record of what this mountain can produce, when it decides to stop expressing itself in 101 eruption pulses per day and begin expressing itself with everything it contains, is a record that does not allow for comfort. Here is where the science becomes not a story about numbers, but a story about precedent, about what the Earth has already done on this island, in this geological zone, and why the phrase, "this has already happened before," carries a weight here that goes far beyond rhetoric. In 1815, on the island of Sumbawa, less than 2,000 kilometers to the south of Halmahera, in the same Indonesian archipelago, a stratovolcano called Mount Tambora erupted in what remains to this day the largest volcanic eruption in recorded human history. The eruption reached a volcanic explosivity index of 7, a number that demands translation. VEI7 means that the volume of material ejected during the eruption exceeded 100 cubic kilometers. 100 cubic kilometers. That is a cube of rock and ash more than 4.5 kilometers on each side, a solid block larger than most mountains, liquefied and detonated into the atmosphere in a geological instant. The death toll from the Tambora eruption was approximately 92,000 people, not from lava flow, not from pyroclastic surges, though those killed thousands in the immediate blast radius. 92,000 people dead primarily from the consequences that followed: crop failures, famine, disease, the collapse of food systems across an entire hemisphere caused by a volcanic winter that reduced global temperatures and blocked sunlight from reaching farmland from Europe to North America. The year 1816 became known in history as the year without a summer. In New England, there was frost in June. In France, the harvest failed. In China, floods and famine killed hundreds of thousands. All of it traceable to a single volcano in the Indonesian archipelago in the same geological family, on the same tectonic boundary as Mount Ibu. This is not speculation. This is documented geology. The evidence is in the ice cores of Greenland and Antarctica, in the sulfate deposits, in the tree ring records that show a catastrophic narrowing in 1816, the year the sunlight did not come. And Tambora is not the only evidence. Closer in time and closer in geography, the December 2018 collapse of Anak Krakatau, child of Krakatoa, the volcanic island that grew from the caldera of the original 1883 eruption, demonstrates with brutal precision how fast a volcanic event can translate into human catastrophe without triggering any of the alert thresholds that conventional monitoring is calibrated to catch. On December 22, 2018, a flank collapse of Anak Krakatau, not a major eruptive explosion, but the structural failure of approximately 64 million cubic meters of the volcano's southwestern flank, generated a tsunami that struck the coastlines of both Banten province in Java and Lampung province in Sumatra within approximately 24 minutes. 437 people were killed. Thousands were injured. Entire beachside communities were swept away by a wave that the seismic network did not initially distinguish from a routine eruption event because it was not generated by a tectonic earthquake. It was generated by a landslide. The warning never came because the system was not configured to detect the specific mechanism that caused the disaster. Ibu's outer crater is breached on the north, a major structural failure of the northern flank, driven by the same persistent eruptive pressure that produces 100 eruption earthquakes per day, would not need to produce a stratospheric ash column to be catastrophic. It would need only to move toward the sea. The coastal communities on Halmahera's northwest shore are there. They are at sea level. The geometry already exists. Tambora was a level 7. Ibu operates daily at level 2. The distance between those numbers sounds reassuring until you understand that volcanic systems do not schedule their escalations. They do not send advance notice. The monitoring is in place and detection is possible, but prediction is not. What the pvmbg instruments can tell you is what is happening right now. The amplitude, the duration, the frequency, the seismic signature of each event. What they cannot tell you is whether tomorrow's first eruption earthquake of the day will be 14 millimeters in 40 seconds, or whether it will be the beginning of something that rewrites every safety parameter currently in place. The question is not whether, the question is when. And the data from the past 17 years of continuous eruptive activity at Gunung Ibu does not suggest a system winding down. It suggests a system that is learning the rhythm of its own escalation. The most recent formal escalation happened on January 15th and 16th of 2025, when a massive eruption sent a column of hot lava and ash 4 kilometers into the sky and forced the National Disaster Mitigation Agency, the BNPB, to evacuate dozens of residents from 6 villages within a 6-kilometer radius of the summit. 6 villages. Families loading what they could carry into trucks and evacuation vehicles, leaving behind the fields they had planted and the houses they had built and the fishing nets they had mended, moving to temporary shelter while the mountain above their coastline continued to fire. That evacuation happened in January 2025. The level 2 baseline continued. By October 1st, the machine had produced 101 eruption earthquakes in a single day, and the alert level had not changed. That is not a failure of the monitoring system. That is a measure of how normalized extraordinary activity has become at this volcano. 101 explosions in 24 hours is, at Gunung Ibu in 2025, a standard operational day. The escalation that preceded the January 2025 crisis had its own more dramatic antecedent just months earlier. On May 16, 2024, following a series of deep volcanic earthquakes and intense shallow seismic activity that indicated magma migrating to shallower depths within the conduit system, Indonesia's Vulkanological Survey raised Mount Ibu to level 4, the highest possible alert designation, the one that carries with it mandatory evacuation orders and aviation red codes. 7 villages were evacuated. Ash columns reached 5,325 meters above sea level on May 17th. On May 27th, after 6 days of relative quiet, the mountain erupted again and sent a column 6,000 meters into the sky. 6 kilometers of ash rising above a mountain that is itself only 1,325 meters tall. The eruption made a booming sound heard clearly at the observation post. Sand rained down on Gamitsi village. A code red VONA, Volcano Observatory Notice for Aviation, was issued, grounding aircraft and rerouting flight paths over the Molucca Sea. Then the ash columns gradually decreased, the alert level was stepped back down, and the mountain settled into its rhythm of constant lower-level explosive activity. Weeks passed. Months passed. By October, it was producing 101 eruption earthquakes per day and carrying a Level 2 classification. The system had returned to what now qualifies, in the language of Indonesian volcanic monitoring, as normal. But normal is a word that carries its own warning here. In May 2020, the largest eruption of the current eruptive period sent an ash column 13.7 kilometers above sea level. 13.7 kilometers. That is 45,000 feet, the cruising altitude of commercial passenger aircraft. An ash plume at that height does not drift toward the next village. It enters the stratosphere. It begins to interact with global atmospheric circulation systems. At that height, volcanic material can circle the planet. At that height, the sulfur dioxide injected into the atmosphere begins to form aerosol particles that reflect incoming solar radiation back into space. The 2020 eruption did not trigger a global climate event. It was not a Tambora or a Pinatubo, but it demonstrated that the pressure available within the Ibu magmatic system is sufficient to produce columns at stratospheric altitude. And that demonstration has not been forgotten by the volcanologists who read the seismic data every morning at the Gamitsi post. Now understand the tectonic geometry that drives all of this, and you will feel the ground shift beneath your understanding in a way that does not fully resolve. Halmahera Island sits at one of the most geologically complex convergence zones on the surface of the Earth. Here, the Philippine Sea Plate and the Pacific Plate interact with the Australian Plate and the Eurasian Plate in a zone of subduction so intricate that the tectonic maps of this region resemble a puzzle with no clean edges. The Pacific Ring of Fire, the horseshoe-shaped belt of subduction zones and volcanic arcs that encircles the Pacific Ocean, passes directly through this zone, and Halmahera sits at a junction within that ring where multiple plate boundaries intersect within a relatively confined geographic area. What this means, in terms of energy availability, is almost impossible to fully quantify. The subduction of oceanic crust beneath the island arc generates the heat and pressure that produces the magma-feeding Ibu's conduit system. The friction between descending plates produces the deep seismic activity, the deep volcanic earthquakes that pvmbg recorded in April and May 2024, indicating magma migration toward the surface. And the interaction of these multiple plate boundaries means that the seismic and volcanic system of the region does not operate in isolation. What happens in the subduction zone to the northwest does not stay in the northwest. It propagates. It communicates through the crust in ways that science is still working to fully characterize. The connection goes further than tectonics. And here's where scientists are careful to say what they can support and what remains under active investigation, but that careful language carries its own warning. Research published over the past 2 decades has explored potential correlations between solar activity, specifically solar wind interaction with Earth's magnetosphere, and patterns of seismic and volcanic release. The mechanism proposed involves electromagnetic forcing of the crust through ionospheric coupling, or through changes in atmospheric electrical gradients during periods of elevated geomagnetic activity. The data remains contested. The correlations are real, but the causal pathway is not yet established at the standard of scientific certainty. What can be said is this: the Earth is not a collection of independent systems. The atmosphere communicates with the ocean communicates with the crust communicates with the mantle communicates with the volcanic systems that reach upward through it, and the sun, the electromagnetic engine that drives everything from atmospheric circulation to ocean current patterns to the charge differential between ionosphere and ground, sits above all of it, constantly in motion, constantly changing. When scientists say the system is not dormant, they are talking about Ibu's magmatic conduit, but the statement applies more broadly than they may intend. Indonesia, as a national whole, recorded 6,480 volcanic eruptions across all its volcanoes in 2025 through the end of September. 6,480 eruptions from a country that contains, again, 127 active volcanoes. These volcanoes do not operate as separate independent machines. They share geological infrastructure. The same subducting plates feeding different magmatic systems at different points along the arc. The same deep pressure gradients communicating through the mantle in ways that can influence multiple volcanic systems simultaneously. When Mount Semeru in East Java produces 2,500 eruptions in the same 9-month period that Mount Ibu produces 2,300, that is not a coincidence of scheduling. That is the Indonesian arc operating as the single living geological system that it is. The Ring of Fire does not have discrete off switches. It has gradients of activity, and what those gradients show in 2025 is a system that has been running near the high end of its historical output range. The pvmbg monitors all of it. The question is not whether any single instrument is working correctly. The question is whether the aggregate signal, the sum of all these simultaneous elevated outputs across a single geological arc, tells us something that the individual measurements, read in isolation, do not. Scientists are careful to say that correlation is not causation. But that careful language carries its own warning when the correlation is this consistent and this geographically coherent. In the month of January 2025 alone, Ibu had erupted more than 1,000 times. The aviation alert, separate from the ground level alert, sat at orange, the third level on a 4-level scale, because ash columns from this volcano pose a documented hazard to commercial aviation across the Molucca Sea Corridor. Aircraft passing through this region carry with them passengers who have no idea that the air their engines are breathing at any given moment might be carrying particulate volcanic matter ejected that morning from a mountain 1,325 meters tall on an island most of them have never heard of. The residents of Duono village on the slopes of Halmahera's northwest coastline have heard of it. They live with it the way coastal communities in high latitude zones live with winter, with the knowledge that the season will come, with the knowledge that preparedness and proximity are in permanent tension, with the knowledge that the mountain has shown them what it can do, and that the memory of ash falling on their rooftops and the sound of a boom heard through the walls of their homes at 3 a.m. is not an abstraction. The people of North Halmahera Regency, approximately 207,623 as of mid-2025, are not unaware of their position. They are aware. They have been told. The pvmbg has maintained its monitoring post in Gamiksi because they are aware. The question that the people of Duono village and Gamiksi village and every other community within the shadow of this mountain's possible escalation would ask, if they could see the seismic data the way the scientists see it, is not whether the mountain is dangerous. They know it is dangerous. The question they would ask is the question the instruments cannot answer. Is the baseline of 101 eruptions per day the new stable rhythm, or is it the prelude to something the exclusion zone cannot contain? The Level 2 alert designation means that the pvmbg has assessed the current activity as elevated but not requiring immediate mass evacuation. It means residents are advised not to enter within 2 kilometers of the active crater and not to enter the 3.5-kilometer northern sector. It means aviation is on orange alert, meaning airlines are advised of the hazard and are monitoring column heights on every eruption. What it does not mean, and what the volcanologists at pvmbg would be the first to tell you, is that the system has been assessed as stable. Stability is a concept that does not cleanly apply to a conduit that has been producing eruption earthquakes continuously since 2008. What has been assessed is the current measurable output. The deep system, the pressure chamber, the conduit geometry, the rate of magma recharge from below, is inferred, modeled, estimated from surface signals. The instruments are exceptional, the models are sophisticated, and the prediction is still not possible. In every honest volcanic risk assessment, there is a sentence that translates in plain language to, "We will know when it changes, and we may not know before it does." On August 22, 2025, there were 150 explosions recorded from Ibu in a single day, with plumes rising to a maximum of 700 meters above the vent. On August 21st, 141 explosions, plumes to 600 meters. On November 18th, 120 eruption earthquakes in 24 hours. These are not single data points. They are a population of data points that describe a volcano operating at sustained high output, varying day to day in its specific numbers, but maintaining a directional trend that, if plotted on a graph across the 17 years of continuous eruption, does not look like a system settling into equilibrium. It looks like a system that has found its rhythm and is testing what lies beyond it. The question is not whether a volcano that produced a 13.7-kilometer ash column in 2020 and was raised to level 4 with mass evacuations in 2024 and is averaging over 100 eruption earthquakes per day in 2025 is capable of significant escalation. The geological record answers that question without ambiguity. The question the instruments are trying to answer in real time, the only question that actually matters to the 700,000 people on Halmahera, to the fishing families of Gamiksi sweeping ash from their doorsteps, to the children of Duono looking at the mountain's silhouette against the morning sky, is the question of timing. And timing is the one dimension that even the most sophisticated seismic monitoring network on Earth cannot resolve in advance with certainty. What the data actually shows is a volcano that has erupted more than 21,000 times in a single year, that has pushed ash columns to stratospheric altitude within the last 5 years, that was raised to its highest possible alert level less than 2 years ago, that is currently producing explosive eruption earthquakes at a rate of more than 1 per quarter hour on active days, and that is built on a breached outer crater with a structural opening aimed directly north toward inhabited coastline. What the monitoring shows is continuous. What the prediction shows is silence. The pvmbg will know when the amplitude exceeds threshold. They will know when deep seismic activity indicates magma movement. They will know when harmonic tremor patterns change in ways that suggest conduit pressurization. They will issue the warning. The warning system is real. The instruments are real. The scientists monitoring them are real and dedicated and working under conditions that most people in the developed world would find difficult to imagine. Stationed in a monitoring post in a village where sand rains from the sky on eruption days. But between the moment of detection and the moment of impact, there is a gap. The gap is measured in minutes. Minutes are not hours. And on an island with limited evacuation routes, a population of 700,000 people, and a mountain that has already demonstrated it, can fire an ash column 45,000 feet into the sky. The gap between detection and consequence is the space in which everything that matters either happens or does not. The monitoring is in place and detection is possible, but prediction is not. The level 2 alert will remain in place until the numbers change. The instruments will keep recording. The scientists at Gamitai will keep watching. The fishing families of Duono will keep reading the sky each morning. And Gunung Ibu will keep doing what it has done every day since April 2008. Breathing, pulsing, firing, escalating and settling and escalating again. A machine that has not stopped in 17 years, sitting on a breached crater in the middle of the most tectonically violent archipelago on Earth, surrounded by 700,000 people who know its name. The 101 eruptions of October 1st, 2025 are already in the scientific record. The 101 eruptions of the next day after that are not. Neither are the ones after that. The mountain does not file notice. It does not announce what comes next. It simply continues. And the instruments keep listening for the moment when what comes next is something other than what came before. That moment has not arrived. The system is not dormant. It is awake. And it has been awake for a very long time.